entre ponentes. Ella es Lamberti, es investigadora predoctoral, pero está a punto de defender su tesis dentro de muy poquito. Ella forma parte del grupo de neuropatías periféricas y hoy nos va a hablar sobre la transducción del dolor neuropático en neuronas somatosensoriales. Muchas gracias.
Buenos días a todos. Soy Lamberti y pido disculpas, pero voy a presentar en inglés porque, aunque sé hablar muy bien español, eso espero, no tengo los términos adaptados para presentar un proyecto científico. So, I'm going to switch in English, and I work in the group of Professor Antonio Ferrer-Montiel and Professor Ana Fernández-Carballar. And my project is about the sodium and thermal TRPs ion channels as a key molecular and functional landmark for chemotherapy in the peripheral neuropathy. First of all, it's important to understand what the chemotherapy in the peripheral neuropathy, or CIPN, means. I imagine that most of you know that the chemotherapy treatment is one of the most effectively and widely treatment for the most types of tumor. But unfortunately, it also hits the normal cells, resulting in the chemotherapy dose-dependent side effects. One of the most important is indeed the peripheral neuropathy, or pain in hands and feet. This disorder may require dose reduction, and it's accompanied by multiple symptoms affecting quality of life. For example, spontaneous pain, paresthesia, and thermal and mechanical allodynia. The problem is that currently there are no effectively treatment or prevention for this disorder. There are different drug classes which induce the CIPN, and one of the problems is that the symptoms are usually drug resistant. In fact, the current analgesic can blunt the perception of pain, but do not modify the underlying damage. Consequently, many oncology administrate high quantity of analgesics, which give a lot of side effects, or they can even decide to stop the treatment for a period, compromising the survival of the patients. Among the different drug classes, the focus of this project was on paclitaxel, or Taxol, which is part of the taxane family and revolutionized oncology, stabilizing the microtubule in a wide range of solid tumor. But the same microtubule stabilization power derail axon transport in neurons, resulting in mitochondrial dysfunction, ion channels remodeling, and ultimately neuropathic pain. The incidence of this disorder is more than 60% of patients affected during the treatment, and up to 30% experience persistent symptoms months or even years after the last infusion. The trophic receptor potential ion channels are our polymodal sentinels of pain, so they are physiologically our ion channels to detect the hot and cold temperature. In 2021, Julius and Pataputian won the Nobel Prize for the discovery of these ion channels. But this project is focused on three of these subtypes: the TRPA1, the TRPM8, and TRPV1. The TRPA1 and the M8 are our cold receptor. Indeed, the TRPA1 can detect the temperature less than 17 degrees, but it can be also activated by chemical agents like AITC, or the active principle of the garlic and cinnamon. While the TRPM8 is activated in a range between 10 and 28 degrees, and it's activated by the chemical agent, the menthol. On the other side, for the TRPV1, it is our hot receptor of the temperature. In fact, it is activated with a temperature more than 42 degrees. Also, the agonist is the capsaicin, that is the active principle of the pepper. Recent studies in our laboratory demonstrated that in a long-term culture up to 10 days in vitro with only one administration of paclitaxel, there was a significant increase of the spontaneous activity in nociceptor, in non-peptidergic and peptidergic neurons, peaking at 48 hours after the treatment, that virtually disappeared after 96 hours. Also, they showed that paclitaxel could increase the sodium 1.8, the TRPV1 and the TRPM8, and the results showed a potential sex dimorphism in favor of female nociceptor. For these studies and for a lot of study in the literature, because these trypsin channels are involved in the development of CIPN, different modulators are being developing to target these ion channels to ameliorate the neuropathic pain. So, starting from this background, we set two objectives. The first one was to elucidate the molecular mechanism of paclitaxel-induced neuropathy, because currently there is a lack of knowledge of the real mechanism of the CIPN. And then, because we saw that the TRPV1 and TRPM8 were the most involved in this disorder, we decided to explore different modulators as a localized analgesic and neuroprotective strategy. To do this, we used a long-term culture up to 15 days in vitro with two consecutive administration of paclitaxel, which is removed the day after, and then we follow the effect of paclitaxel over time at 0, 48, and 96 hours post both treatments. The consecutive administration of paclitaxel were done to go closer to what really happened in cancer patients who undergo multiple cycles of chemo. To do this, we first seed the neurons on a crystal to study sensory neurosensitization and TRPS ion channels functional evaluation. And we conducted different experiments like the patch clamp, and then we confirmed the result with the qPCR and the immunocytochemistry. On the other side, because it's known that paclitaxel causes action retraction, we used a powerful platform to study this disorder that is called microfluidic chambers. In microfluidic chambers, there are two macro channels divided by microchannels. So we could see the soma on the upper compartment, and after this, thanks to gradient of medium volume and neurotrophic factor, we could see the axon growing on the other compartment. So at this point, we treat with the paclitaxel only the axonal compartment to study over time the axonopathy induced by paclitaxel. So the results showed for the functional data that a dual paclitaxel treatment induced a long-lasting hyperexcitability, but also the paclitaxel could increase the TRPV1, the TRPM8, and the sodium 1.8, in particular after the second treatment of paclitaxel. Also, studied in the microfluidic chambers, we could see that repeated paclitaxel exposure causes irreversible axon retraction. This means that when we follow these results over time, we could see an initial axon retraction at 48 hours post the second treatment, which do not recover after 96 hours. Then we focus on the modulators of these trypsin channels with the focus of ameliorating the neuropathic pain. And in collaboration with Professor Tracy Pirali, we found this compound, which was a dual agonist of the TRPV1 and cannabinoid receptor. this crosstalk is important because in nociception there are this crosstalk between the TRPV1 and the cannabinoids. In fact, for example, the cannabidiol can target, activate the cannabinoid 1 receptor, while indirectly or via intracellular pathway desensitize the TRPV1. So we found this compound called compound 41 that had also selectivity over on the TRPA1 and the TRPM8 that are also involved in the CIPN, and it had high metabolic stability. Another compound we found was the TRPM8 antagonist that is also increased during the paclitaxel treatment. And we found in this case the compound 23, which was made with the easy, green and fast synthesis, and it was a potent reversible antagonist of the human channel TRPM8. And with the high concentration, it could block had a multi-target effect even on the TRPA1 and TRPV1. And when it was tested in vivo, it could effectively reduce the cold allodynia induced by the oxaliplatin, that is another chemotherapy drug. So finally, this project was part of a big consortium called PIANO, focus on the imaging and therapy of chronic pain in dorsal root ganglion, and I started this journey here in this university in November 2021. And in this year I had the opportunity to do 2 secondments. The first one was in a medicinal chemistry laboratory in Professor Pirali's group, where I had the opportunity to learn how to synthesize different compounds targeting different ion channels. And then after 1 year, I spent 3 months at Polypure, that is a Norwegian company specialized in the pegylation of different compounds, where I had the first idea of the translational scale-up of our job. So in this year, at this point, I developed a CIPN in vitro long-term culture, and then I tested different TRPS ion channel modulators. And at the end, I focused on the compartmentalize this in vitro model to study the effect of paclitaxel on the peripheral nerve endings. So, thank you for your attention, and I would like to thank my groups of the peripheral neuropathy research group. Thank you.
Muchas gracias. Igual que antes, tenemos tiempo para una preguntita rápida, si alguien quiere hacerla.
En español también.
Y si no hay preguntas, nos podemos despedir antes.
Gracias.